Just extremely quickly, while they are setting up the slide, our next speaker is Delfina Martinez Pandiana. That is a postdoctoral researcher at the Center of Wiskunde and Informatica in Amsterdam, specializing in high-level multimodal sense-making and misinformation detection. The floor is yours. Thank you very much.
Thank you. Hi, everyone. Thank you to the organizers for this great event. I'm really much looking forward to discussing more. And I think there's a lot of points of contact between a lot of the conversations that we've been having and also the talks. So the research I will be presenting, it stems from part of my doctoral thesis, which focused on detecting high-level meanings in cultural images and how computer vision pipelines are echoing certain specific perspectives. I'll be delving into the technical challenge of addressing subjective bias and contextual factors in data labeling. But before we get into the technical nitty-gritty, I want to start with a story that some of you may be familiar with. So in 1769, inventor Wolfgang von Kempelen impressed the court of Empress Maria Theresa of Austria with a fabulous creation. He was inspired by the fascination with automatons, and he presented the mechanical Turk. This was an automated chess marble in a large cabinet featuring a mechanical Turkish player. Put the colonial idea aside. To showcase the invention, Kempelen would open the cabinet and reveal the complex arrangement of cogs and gears and levers, and he would strip apart the model to expose the entirely mechanical nature. After winding it up, the mechanical Turk would start a chess game, move pawns, tip the board, nod and bow, and amaze the audience. So it would tour European courts, won nearly every chess game, and even faced notable figures like Benjamin Franklin. So for decades, Kempelen would insist on its completely mechanical nature, but its exact workings were a mystery. And speculations ranged from magic to hypnosis to hidden dwarfs. It was only in the 1850s that the inner functions were revealed. And it turns out that the chess cabinet was larger than it seemed. It had secret compartments that allowed a full-grown, skilled chess player to hide. So the mechanical Turk was celebrated as automation and intelligence, but it was a clever illusion. So today, much of the developments in deep learning, and especially in visual analyses, are sometimes described as magical. However, this magic, much like Kempelen's mechanical Turk, is an illusion, in the sense that much of what happens behind the scenes is what allows for the intelligence to happen. So these advancements in AI are fueled by human workers. Who here has heard of Amazon Mechanical Turk? Okay, so this is where the name comes from. So it's a platform owned by Amazon that mediates tasks like data collection and image labeling and uses crowd workers, nicknamed Turkers. And most of the label data that feeds CV meaning computer vision pipelines, comes from these platforms, and they compensate workers meagerly, so sometimes very much below local minimum wage. So akin to the cramped space inside Kempelen's mechanical Turk, millions of people, mostly from the global south, and often subject to exploitation, annotate the masses of data that mostly US companies need to train their AI models. And often this is done in dingy internet cafes or really cramped up office spaces. So these workers are the invisible labor behind much of the AI development we're seeing today. But what exactly is this labor? Well, most of the computer vision models used to automatically annotate visual data, including cultural heritage data, are supervised. So they rely on heavily, meticulously labeled data sets for effective training. And these labels are often referred to as ground truths. They define the problem's truth that the machine learning model is aiming to solve. So human annotators typically assign or verify these ground truths. But critically, once they are established and validated by humans, these ground truths are considered gold standards. So these golden annotations enable the automation of the annotation process itself. So they are used to train other labeling systems. So the annotation ecosystem hinges on the reliability of these golden ground truths. Increasingly, graph-based resources like the one you can see on the slide, this is Visual Genome, are used to semantically capture the annotations and how they relate to an image. So these can serve as optimal structures because they allow for relationships between objects and scenes to be explicitly put there. But while this is a great step forward, there's still a semantic issue in that these annotation labels are integrated into the data sets and critically thus fed to the models at face value. So they are fed as objective truths in a vacuum rather than as beliefs specifically bounded to an annotation context and thus to a situated subjectivity. At first, we may think, well, this is not really that relevant for most computer vision, only if we're dealing with labels that are incredibly subjective. However, if we look at the golden data closely, it becomes apparent that incredibly subjective information can enter the purportedly objective image annotation pipelines. So as an example, I manually scanned the Visual Genome dataset, which is considered one of the gold standards in computer vision, and found some quite striking examples of how subjective knowledge is entered into these pipelines. So these examples make clear that the cultural context in which an annotation is added to an image is critical because it can determine what the computer vision model learns is strange or weird or disgusting. So for whoever annotated the bottom left image, maracujá, which is the passion fruit, I don't know if it's called passion fruit, but this fruit probably is not part of their normal cultural context, so they classified it as something that is probably disgusting. So probably this person doesn't come from a place like Brazil or Argentina. And while some labels, let's say computer, in one of the images may be objective enough, other tags such as homeless person are integrated at the same semiotic level. So can or should such an annotation be considered a global ground truth? As you can imagine, what a person without a home looks like depends on the cultural context. In many countries, someone who has a computer will most likely not be in the same cultural context of the homeless people in that situation. So I hope that these examples can illustrate what most humanists have a hunch for, which is that labels used in computer vision tasks are frequently based on social constructs that are contested, unstable, and thus it becomes incredibly important when we are tagging images that depict human beings. The act of creating or using a training data set in AI systems involves compressing the complexities and diversities of the world into discrete taxonomies. And the process of designing and assigning these categories inherently involves political, cultural, and social choices. So this moment of classification is a moment of powerful decision-making, and it often occurs without the consent of those being categorized. So I wanted to highlight the subjective and contextual dimensions embedded within the AI world building architectures, and prompt some critical questions about who has the authority to make these choices, but also under what guidelines and under what circumstances are these choices being made. I find the trend of decontextualized labels even more problematic with recent trends in computer vision and cultural heritage. This was what most of my dissertation was about, which is how these computer vision tools and methods are encroaching on increasingly high-level semantic annotation. So I surveyed the state of the art. I don't know if it's visible, but here you can see a table of the kinds of tags that are increasingly automated that are going forward into more and more abstract and nuanced labels, so capturing complex ideas, emotions, violence, political bias, abstract qualities like beauty, trustworthiness, even who is the most influential person in a room, things like that. So this recent shift has changed the expectations of computer vision models. As Michael said yesterday, what kinds of questions are we asking of this data and thus of these models? Some of these are values and symbols in advertisements, emotions in paintings and artworks. So most of these examples adhere to the ground truth image label logic, wherein the connection between these two things is enough to train a model. So now I'm getting to the core of the question, and I will talk about my approach, which is how can we contextualize these labels to move beyond the contextualized pairings, but also technically, how can we achieve this in a way that is machine understandable and not just for humans to talk about the problems of the data or of the models? My proposal is called SituAnnotate. It's an ontology and knowledge graph. And at the core is the idea that the situated context can be directly encoded into the data itself. So the first part of this is more the theoretical grounding based on situatedness, that understanding objects and their functions requires contextualizing information. This has been recognized across archaeology, anthropology, feminist studies. But the idea is that in computer vision, we can also distinguish between vision and visuality. Visuality reveals societal, cultural, historical influences on how we perceive visual information, and see how today most annotations in computer vision are presented and consumed by models as if they were from a view from nowhere. This made me think of Donna Haraway, what she calls the God trick, which in situated knowledge is. And her epistemological approach emphasizes the limitations of Western technoscientific quest for objective truth and critiques the traditional metaphor of vision, calling it the gaze that makes the unmarked category claim the power to see and not be seen, to represent while escaping representation. So that was kind of the main inspiration for me. Yesterday, Melvin mentioned situated data analysis, which provides with a method for analyzing how data is situated and always partial and biased. And this is the direction that I'm following. But I'm trying to go into a further step technically to make this both human and machine understandable. So to do this, I use semantic technologies, which is what most of my background is on. And I try to imbue data annotations with context with an ontology. An ontology serves as a structured framework that defines concepts and their relationships, enables the creation of a knowledge graph, and these knowledge graph edges can carry specific semantic meanings defined within the ontology. So this means that we can curate and encode information in triples, and then we can have a triple store in RDF, and we can automatically query that information and reason over it to gain deeper insights into the nature of the data. So at the core of SituAnnotate, there's 3 classes. So going beyond the binary relationship between an annotation and an entity, in this case, images. In SituAnnotate, it's a triangle. You have the annotation, you have the entity that is annotated, and you have the annotation situation. So one can still query this and have the traditional table-like entity annotation, but if a person wants to query and understand the situation that connects those two, a lot of information can be encoded there. So to develop this ontology, I use the extreme design methodology, which identifies scenarios that represent the types of questions that someone might want to get from the data, and then we transform those into competency questions. But overall, the core idea is that instead of having two first-class citizens, that's what they're called in RDF, we have the annotation situation at the first-class citizen level. So the ontology is designed to situate annotations within a broader context, so to connect them not only to a described entity, but to the annotation situation. And basically, each of these three components, which are the annotation situation, and the annotator, can have many more properties added to them, depending on what kind of data is available. So, for example, exploring the annotation situation, this class encapsulates the state of affairs in which an annotation occurs, and it can include details such as the moment in time, the specific place in which it was added, the involved annotator, any remuneration scheme involved. This is inspired by the Amazon Mechanical Turk shift of invisible labor, the data set to which the annotated entity belongs, guidelines that were used. Then on the annotator front, a key feature is that instances of this class can be either artificial annotators or human annotators, meaning that the ontology already allows for the inclusion of annotation situations in which models are making the labeling. And the human annotator is also subdivided into individual human annotator and human annotator community. So ideally, or perhaps theoretically, it could be interesting to have individual human annotators data about who it was, who they are, where they're from, what their political or religious leanings are. But most of the times this is not possible for privacy and maintenance issues. But we do generally have data about the annotator community. So saying, okay, this data set was annotated with Amazon Mechanical Turk workers in the Philippines in 2022. That kind of information can also be added. And then moving on to the annotation class, we can also connect this to a lot of semantic resources that are out there, like WordNet, FrameNet, all of these linguistic resources that might allow us to also reason over the kinds of labels that are being assigned from different annotation situations. In order to specialize in the image annotation situation, because the SituAnnotate framework can be used to annotate any kind of entity. But for images, because I work with computer vision, I also did a module specializing on the kinds of knowledge we might want to also encode. So specific pixel areas, RGB values, all of this is already put into the ontology itself. And over here you can see an example of, in purple would be the entity of one image. And in red would be two labels that were assigned. One would be person almost naked, and another one would be person in traditional indigenous garment, for example. So these two annotations that refer to the same pixel area, if we want, we can query and understand where those annotations come from. So it allows for the overlap of different annotations on the same pixel area. I'll try to go very quickly, but I did some experiments on the ArtStract dataset, which is a dataset I compiled of cultural heritage images, meaning advertisements, paintings, and historical photographs that were tagged with abstract concepts. They were made, I did this by combining different resources. And then I created the knowledge graph based on this and compiled a lot of information coming from computer vision models on the kinds of information that visual transformers and convolutional neural networks were extracting, so objects, emotions, scenes. And developing a Python script, you can query the knowledge graph and get a human understandable, here in orange, explanation of how an image and a label are connected. So here it says, oh, this image has the label impressionism to describe the art style. It has an annotation strength of 62%. It was done this day in Italy. It was done by an artificial annotator called blah, blah, blah. It has a visual transformer backbone, and it was pre-trained on this data set. So quickly, this can be used for training downstream tasks. So instead of using clip embeddings or CNN embeddings, like it has been mentioned in many lessons, we can also embed the knowledge graph itself. So we can represent an image as the node in the graph and have an embedding. And I did this for the downstream task, and I found that the performance either stayed the same or it was a little bit better, but critically it allowed for explainability. So one can then query the graph and say, oh, okay, these are the more relevant nodes, or this is what these images have in common in the semantic level. And this is my last, or almost last slide, is what I'm doing now, which is to annotate harm in images, so especially in memes. And that means propaganda, conspiracy theories, hate speech, cyberbullying. And first of all, the complexity of doing this makes me think of all of these lessons about situated ground truths. But in the last few months, you might have seen these news about how much of the content moderation and harmfulness is being shipped to African countries and African workers. So I think that I want to finish with the idea that we need more thought on how we can adopt situated perspectives and anti-colonial perspectives to ensure that the process of annotating ground truths is not only ethically sound, but also technically relevant. Thank you.
Thank you very much. It was fantastic. And do we have any questions? Yes.
It was great, Delfina. Thank you very much. Could you go back to the slide with the 11 scenarios?
Yes.
So, could you just say a little bit more about the 11 scenarios? How they? I mean, I can see they're the ones that collect information. Is that right?
So this is part of the design and development process of the ontology. And by talking with people I was working with, we came up with basically scenarios in which we would like more information. Yeah. So an example would be, I would like to understand where most of the annotations were made, or how geographically distributed these annotations were. So the 11 scenarios are like the 11 key things that we identified we wanted to do.
Okay, yes, I thought so. Thank you very much. It's great.
Any other question? Sorry. Yes, please.
Thank you so much for your presentation. I think this is fantastic work. Mike, you've obviously done a ton here that you have not had a chance to talk about. When it comes to these complex, contested categories, value judgments, and so on, how can we manage to have the right vocabularies to support this kind of work? Because it's very well to have the ontological structure, but it all comes down to changing language, discursive communities, and so on. Could you speak a little bit about that?
Yes, great question, thank you. I think, as you might see here, I started with this idea of harm, for example, and I thought, okay, I can just go into identifying the structures and biases. And no, first I've been spending more than a couple months on identifying the vocabulary. That's what I'm trying to do here. What is considered propaganda, what is considered hate speech or graphic content. And what I think is critical is that, coming from more of a computer science perspective, many times these taxonomies are just created on the fly. It's like, we want to detect hate speech, so let's hate speech versus non-hate speech. So that is something that I'm trying to do now, is work more with media studies scholars to at least have taxonomies that have a provenance. So research or academic provenance that then can be linked in the ontology. So saying, okay, this image was tagged with hate speech as defined by XYZ in this context. So I think that's also the flexibility of using semantic technologies, is that allows us to include more and more information if we want to situate even the labels themselves. But it is a very, very hard thing to do and not, let's say, overpopulate a knowledge graph with this.
Thank you.
Another question? If not, I may have some. Many, but I would like to ask you to actually elaborate a bit on the possibility of encoding polysemic knowledge in a knowledge graph. Like, is the ontology the right tool? How can we do that? And how are you doing it?
Yes, I think that's also a great question. Yeah, okay, this is pretty visible. So you can see that in the annotation, we can have a property connected to the lexical entry, and then the lexical entry can be connected to a concept, and that includes WordNet concepts. So that allows for polysemic connections, because in WordNet we have the word senses, so for example, the palm of the tree and the palm of the hand. So by having the connections with WordNet or other resources for polysemy, we can also query only entities that are connected to that word sense. So I think relying on other resources that are out there, especially from computational linguistics, can really help. Yeah, that's what I would say.
Thank you. I may have also another one. Just very practical. Did you, by any chance, or are you willing to create description for the major data set? I'm thinking about, for example, WikiArt, which is used a lot, and trying to understand how it's made in order that other people in the community can reuse this resource within their knowledge graph or model.
Yes. So for these 4 data sets, so Artemis, which is based on WikiArt, the Tate Gallery, collection metadata, Advice, and Artpedia, because I used them in the ArtStrike data set, I did include what I could find, not in a super, super deep dive, but whether it was crowdsourced, where it came from. But I think there is a lot of potential in doing a deeper dive and trying to encode this for the community to be able to reuse. So that's a great idea. Thank you.
Thank you very much. If there is one last question.
There's time just for one question. Thank you very much. I wonder if you have thought about extending this work to other cases of annotation. For example, in museums and libraries, the metadata that we have on books and so on, it's all situated annotation made by conservators, archivists, and so on. So it should also be. Oh yeah, it's better that way. It should also be linked to these kind of things. And have you thought about how to inject this new information in databases, in institutional databases and so on, so that we can also know that this information has been made by AI or by someone else, that the curators, for example?
Yeah, I don't have that much experience with how these cultural heritage institutions, like whether many of them are used to the RDF, let's say, perspective, more graph-based or triple-based perspective. I think if that is the case, then this can easily be implemented, just reusing some classes of the ontology and adding information. I think if it's more on a traditional tabular database, then that becomes hard, and that's the power of a graph, if that you can have first-class citizens in the sense of situations being nodes. So I would think that cultural heritage institutions that already use graph-based databases can easily implement or, yeah, like additionally put a layer of SituAnnotate, but I don't know about tabular databases.
Thanks.
Thank
Thank you very much for the great presentation.